Newton's first law of motion, or the law of inertia, is when a body at rest remains at rest, or, if in motion, remains in motion at a constant velocity unless acted on by a net external force. The coin is remaining at rest, and it is going to stay at rest until a net external force acts upon it. Thus, the coin has inertia. However, the card being moved is a net external force acting upon the coin, and this causes the coin to move into motion at a constant velocity until it hits the bottom of a cup. Once the coin hits the bottom of the cup, it is once again acted upon by a net external force, which forces it to go into rest. Then, the coin will remain at rest until another net external force acts upon it. However, in the demonstration, no other force is acting upon it, so the coin will remain at rest at the bottom of the cup. Newton's second law of motion is that acceleration equals sum of force over the mass, which equals net force over mass, or sum of force equals mass times acceleration. This means that the acceleration of the object is dependent upon two factors, which is net force and mass. So if the same amount of force is acted upon between two different objects with two different masses, the object with the lighter mass will move a greater distance and accelerate a greater distance than the object with the greater mass. This is shown with the ball and the car. The ball has a relatively light mass, and so when I flick it, it travels a pretty good distance across the carpet. However, when I flick the car with the same amount of force, the car has such a heavy mass that is extremely greater than the ball that it barely even moves. In fact, it does not even move at all. Newton's third law of motion, or the interaction law, is whenever one body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. So the car is acting a force onto the road, and the road is acting a force onto the car. The car is acting a backwards force onto the road. However, the road is acting a force that is opposite in direction, although equal in magnitude, onto the car. This then causes the car to propel forward instead of going backwards.